In this video we're going to look at subroutines. But before I start on subroutines, I just want to draw your attention to some of the common subroutines that are already inbuilt within the program, which are time delays. Okay, so inbuilt for us we have got a 1 millisecond, 10 millisecond, 100 millisecond and 1000 millisecond time delay already built in. So a subroutine is some repeatable code. There are some inbuilt ones for us. These time delay are ones that we've got, and analog to digital conversion, ADC, are another quite common one. The microcontroller will go off and execute these codes, so it will go off and execute and give us effectively on this one whatever time delay we asked for, and then it will come back and return to the program. So how do we call a subroutine? Well, we use the call command. So if I want to create a 1000 milliseconds, then I use call 1000 milliseconds. So that would this command here, the actual subroutine, sorry, it was for 1000 millisecond delay is called wait 1000 milliseconds. So it goes off. This code, we don't need to know what it is. It gives us 1000 milliseconds delay, and then it would come back to this line here, which is whatever we carried on with. Now, if we're going to create a subroutine ourselves, say that we want to create a 5-second subroutine, 5-second delay that we can then use time and time again, then this is how we do it. So we're going to create our 5-second subroutine, so I'm going to call it wait 5 seconds. Wait 5 sec. Okay. So the first thing that we need to do is to save the working register when we enter a subroutine. The reason why we do this is when we enter a subroutine is working registers get used within programs, so we need to keep it nice and safe and then restore it once we've finished it, and it just keeps everything ticking away quite nicely. So the first thing we need to do is save the working register. Now sometimes the working register, you can equate it to a name, so you quite often see in some of these codes wsave. I'm not going to actually use, I'm just going to use a register. I'm going to put it into register rather than equate a register to a name. So there we go. So we've put the working register into register B20, and then I'm just, same as we've done on a previous program, I'm going to set up my count variable as 5 because I want to create a 5-second delay subroutine that I can use. So I'm going to use a similar program to what I did before, and then I'm going to call wait 1000 milliseconds because that's I want to do 1000 milliseconds. I'm then going to decrement my count variable, if it's not, we've not done this 1,000 times, done it 5 times to create our 5 seconds delay, then I'm going to tell it to go, I'm going to go to back to this point here, and then if it has, then I can carry on with the rest of the program. So what does the rest of the program consist of? Well, I need to restore the working register back. So I've just put a couple of annotations in. So here I've restored the working register from it. Not in B0, is it? Let me just correct. There we go. So the working register, no, it's not in B20. There we go. So restored the working register because we put the value in B20. And the last thing we need to do is exit our subroutine. So the way that we exit our subroutine is we use the command return. And that allows us to go back to where we left off. Okay, and that's it. So now we've wrote our own subroutine to give us a 5-second delay. So in our program, all we have to do is use the command call, and what we're calling wait 5 seconds, and when we do that, it will come along, microcontroller will come along, execute these lines of code, and then once it's finished these lines of code to give us our 5-second delay, it will then return back to where we left off. So nice and easy. One last thing about our subroutines, the good thing about subroutines is we should be able to test them in isolation so that we can prove that they work on their own before we then plug them in with everything else. So that's quite a useful feature to be able to do, to be able to test things in isolation, and then we narrow down when we have any faults. Okay, that's it. That's all for now. Bye.